Bismillahirrahmanirrahim. Another example of simple harmonic motion. The topic on which I am going to discuss is another example of simple harmonic motion, which is called simple pendulum. Simple pendulum. Simple pendulum. Simple pendulum. Simple pendulum. When a small metallic mass, when a small metallic mass, also called bubble, also called bulb, is attached attached to an inextensible 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 and weightless string and weightless weightless string weightless string. It is called simple pendulum. It is called simple pendulum, is shown in figure. Is a pump support. Let's say here this point is called pump support. It is a weightless and extensible string, and this is called small metallic mass is called bulb. Of mass M. This point, let's say P, is called mean position. It's called mean position. And this point, let's say Q, it's called extreme position. It's called extreme position. And at extreme position, when the body is displaced, so certain angles making with this mean position is called, let's say, theta. If we displace the bulb, if we displace the bulb from its mean position P, let's say P, to the extreme position, let's say Q, and then release it. It will move towards P. It will move towards this P. It will move towards P under the force of gravity and start an oscillation and start oscillation. Two forces are always acting on a bulb of mass m. One is called downward force. W is equal to mg. And upward force, this is called tension. Tension is the force exerted by the string equal to the weight of the suspended body when the body is at rest. Two forces are always acting on a bulb of mass m. Two forces are always acting on above of m mass m downward force W is equal to mg, and upward force equal to T. At P this point, at P W is equal to mg. At P W is equal to mg is equal to T, and so the pendulum is at rest because both the forces cancel each other, and so the pendulum is at rest. At point Q, at this point Q, the weight force can be resolved into two rectangular components. Because the weight is acting in this direction, W is equal to mg, and tension is acting along the string in this direction. Now this force can be resolved in two components. Let's say this component is called W parallel to the tension is equal to mg cos theta, and this component is W perpendicular is called equal to mg sin theta. Now since restoring force is toward the mean position, so this force provides the restoring force, the required restoring force. That is, if restoring force is equal to mg sin theta, if we displace the bulb from the mean position to extreme position, let's say x, and the pendulum length is L, so then if restoring force is equal to mg sin theta, also according to Newton's second law, ma is equal to mg sin theta. This cancel with this one, so a is equal to g sin theta. For small theta, x sin theta is equal to x divided by L. A is equal to G into restoring force act along the mean position toward the mean position, so minus sign. Here this is called restoring force minus, and this sin theta is equal to x divided by L, because for small theta sin theta is equal to x divided by L, or this can also be written as a is equal to g divided by L into minus x. Since g is constant and length is also constant because it is an inextensible string, so this can also be written as a is equal to a is proportional to minus x. Thus the motion of simple pendulum is SHM. This motion is an SHM motion, and this motion mass attached to a string system is also an SHM motion. SHM motion.